Hi guys, my name is IBM and greetings from Mongolia, Asia. And today I wanted to solve Physics 970212 February-March series. This is 2022. So one of my students asked me to solve the 2022 papers, so I'm going to try my level best to solve them before the end of April. So without wasting time, this is my email, cvia22@gmail.com. Many students write me and ask for my email. That is my email address that I use often. So without wasting time, I would like to take you to the question paper, Physics 970211. So question paper. So here is the question paper. We are used to most of these. So February, March 2022. Paper is 1 hour and 15 minutes. It's multiple choice questions. So without wasting time, I will just take you to the question paper. You can read through the instructions, the formula, and the list of constants. So what could not be a measurement of a physical quantity? So if we want to identify a physical quantity, number one, we must ensure that it has a unit. We must ensure that it has a unit, and it should be having a magnitude. All these are magnitudes, so we have already tested, we can see that they are all magnitudes. Now we just check the units. I think Kelvin is a unit, that is a physical quantity. Terameters, this is terameters, that is a unit, that is a physical quantity. I will check if joules per Newton per meter is a unit. Let's check. Joules divided by Newtons divided by meters. That is how we write joules per Newton per meter. You notice that joules is a unit of work, but also work done is force times distance, and force is in newtons and distance is in meters. So it's like 1 joule is equivalent to 1 Newton per meter. So it's like we are dividing Newton per meter by Newton per meter. So this cancels with that. So this one is equal to no unit. So therefore this one, this is equivalent to no unit. This is equivalent to no unit. And since that is equivalent to no unit, so it means this is not a physical quantity. So the answer is going to be B. A computer memory stick is labeled as having a storage capacity of 128 gigabytes. The letter B stands for byte, which is a unit. What is the equivalent storage capacity? So 128 gigabytes is the same as, of course, giga is 10 to the power of 9. So this will be 128 times 10 to the power of 9. That is bytes. So if we check the answers given here, we don't have 128 times 10 to the power of 9, but we can move 2 steps so that we have 1.28 times 10 to the power. Since we have moved 2 steps to the left, so this becomes power 11 bytes. And this makes our answer to be automatically B. A man of mass 75.2 kilograms uses a set of weighing scales to measure his mass 3 times. He obtains the following readings. Which statement describes the precision and accuracy of the weighing scales? Now for accuracy, the average value should be very close to 75.2 kilograms. This is for accuracy. For accuracy, the average of the readings should be very close to the true value. Let's check that. So this means the average of 80.2, 80.1, and 80.2 cannot give us a value very close to 75.2. You can even check. So 80.2 times 2 plus 80.1 divided by 3. So the average is approximately 80.2. So the average is not close 80.2 is much bigger than 75.2. So we can say for accuracy, we can say there is no accuracy. So wherever they say there is accuracy, so it is accurate, that one we cancel out. So we cancel out this one and we cancel out this one, which means A and C are not correct. Then for precision, the range should be very small. The range should be very small. So they're saying which statement describes the precision and accuracy? So for precision, we find a range. For precision, we can find a range. So the range is going to be 80.2 minus 80.1, which is equal to 0.1 kilograms. So they are precise to 0.1 kilograms. So let's check. B is saying not precise to 0.1 kilogram. They are precise to 0.1 kilogram because the range is 0.1. So B is wrong. So that means the answer is D. They are precise to 0.1 kilogram because the range is 0.1 kilogram, but they are not accurate to 0.1 kilogram because you notice the difference between the average value and the true value is much bigger than 0.1. So the answer is D. Which statement about scalar and vector quantities is correct? Of course, we know scalar quantities have magnitude only. Vector quantities have both magnitude and direction. So a scalar has direction, that is not true. A scalar has magnitude, which is true, but not direction. I think that is very true. A vector has direction, but not magnitude. A vector has magnitude too, and direction. A vector has magnitude, but not direction. A vector has both magnitude and direction. So the answer is B. A scalar has magnitude, but not direction. How can the acceleration of an object be determined? By definition, we know that acceleration is the rate of change of velocity. The rate of change of velocity. And you notice that change in velocity with the time could be the gradient. The gradient of a graph of velocity against time. So let's check. From the area under displacement time graph. Area under displacement time graph, that one does not give us acceleration. Area under velocity time graph, this one gives us displacement. The gradient of a displacement time graph, gradient gives us velocity. And lastly, from the gradient of a velocity time graph. So gradient of a velocity time graph is the one which gives us acceleration. This one gives us velocity. Area gives us displacement. So the answer is go. And then gradient of velocity time graph, this one is the one which gives us acceleration. So the answer is going to be D. A sprinter takes a time of 11 seconds to run a 100-meter race. She first accelerates uniform, that is a constant acceleration from rest, that means initial velocity is 0, reaching a speed of 10 meters per second. So when we see uniform acceleration, it means equations of motion can apply. So immediately I will first look at that first part. Let me first find the time this person accelerates to reach because we are going to find what is the uniform acceleration of the sprinter for the first part of the race. For the first part of the race, we want the uniform acceleration. Okay, so we know that if the acceleration is uniform, then V could be equal to U plus AT. V reaches 10 meters per second starting from 0. Then the acceleration is, let's say it is A, and let the time be T1. So it means the time T1 is going to be equal to 10 divided by A, not that equation there. She then runs at a constant speed of 10 meters per second. Constant speed of 10 meters per second, that means the acceleration there is 0. Until the finish line. Okay. Let's first find the distance she travels while moving. Using S, I'll use S equals to ut plus a half at squared. Remember, initial velocity was 0. I'm looking at a situation where she accelerates uniformly. So the distance she moves while accelerating is s1. I'll call it s1, equaling to initial velocity is 0. So ut becomes 0. So this will be a half times the acceleration, which is a, of course, times t1 squared. Okay. Remember, t1 was 10 over a. And now we are having s1 is equal to a half a t1 squared. Then when she runs at a constant speed, where she runs at a constant speed, then the distance she moves, of course, if I use s equals to ut plus a half at squared, at constant speed acceleration is 0, so I'll just simply say s2 is going to be equal to the speed, which is 10 meters per second, then times the time this time will be t2. So the time here is t2, the time here was t1. So this is the distance she covers at acceleration, then this is the distance she covers when she's moving at a constant speed. Okay, so it means if I want to find total distance, because the race is 100 meters, so the total distance is going to be the sum of those two. So total distance is going to be s1 plus s2, which is of course a half times the acceleration. Remember, the acceleration was 10 divided by a, but t1 was 10 divided by a. So I'll just simply say a half a t1 squared, then plus 10 t2. I'm just adding this equation to this one here. But s1 plus s2, the total distance was 100 meters. So I'll say 100 equals to a half is 0.5 a t1 squared plus 10 t2. Okay. Now the total time is 11 seconds. The total time taken is 11 seconds. So that means if I want t2 in terms of t1, I will set t2 is equal to 11 minus t1. So it means where there is t2, I'll put 11 minus t1. So I will still say 100 is equal to 0.5 times the acceleration times t1 squared plus, where there is t2, I'll put 10 into 11 minus t1. Okay. So when I simplify this, remember I have to replace where there is t1, I'm going to put 10 over a. So where should I do the remaining? Okay, let me do the remaining working this side. So I now have that 100 is equal to 0.5 times a, where there is t1 squared, I'm going to put there 10 over a. Remember t1 was 10 over a, but squared. Then plus 10 into 11 minus t1, which is 11 minus 10 over a. Okay, so I have to solve this. So this is going to be, I want to solve this very fast. Okay, so this is going to be 100 equaling to 0.5. This is going to be 10 squared over a squared, so 1 a cancels, so this will be times 100 over a plus, this is going to be 110 minus 100 over A. So if I multiply everything by A, this is going to be 100A equaling to 0.5 times 100, which is 50, plus, I'm multiplying everything by A, so this is going to be 110A minus 100. So when I collect like terms, I have 100A minus 111. So this is going to be negative 10A equaling to negative 50. So which means A is going to be 5 meters per second squared. Okay, so I did this the long way, but you could have a shortcut. I just tried to show every step, but I could skip several steps here. So this gives me acceleration as 5 meters per second, which makes the answer to be D. Okay. The number 7, a single horizontal force F is applied to a block X which is in contact with a separate block Y as shown. The blocks remain in contact as they accelerate, which means they have the same acceleration. Let's say the acceleration is in that direction, it is the same. Along a frictionless surface, air resistance is negligible. X has a greater mass than Y. X has a greater mass than Y. So let the mass of this one be mx. Let me say m1. The mass of this one is m2. And we are saying m1 is greater than m2, which is fine. So let's consider the forces acting. At the point of contact here, the force X exerts a force on Y. I'll call that force Fy due to X. When I say Fy over X, it means F on Y caused by X. Then I'll also say the force on X caused by Y, I'll call it F on X due to Y. And remember, by Newton's third law, F on Y due to X is the same as F on X due to Y. The forces are equal but opposite. That is by Newton's third law. But then let's use Newton's second law. By Newton's second law, the resultant force on X, which causes acceleration, I'm looking at X, is going to be m1 times the acceleration, which I'm going to call A, should be equal to, if they are moving to the right hand side, so I'll say is going to be equal to F minus the force which is on X caused by Y, which is Fx due to Y. Okay, so that is the resultant force on X which causes the acceleration. Okay, so which means F on X due to Y should be equal to F minus m1 times A. Then let me look at a block Y. By Newton's second law still, the mass on block Y is m2 times the acceleration is the same, should be equal to, the only force acting on block Y is Fyx. So this is going to be equal to Fyx. So Fyx is equal to m2 times A. Okay, so we have this equation here and this one here. Remember, by Newton's second law, the two forces are equal but opposite. Fyx is the same as Fxy by Newton's third law. So let's see the question. Which statement is correct? The acceleration of X is equal to force divided by the mass of X. The acceleration of X is, this is not true. We can see acceleration is F minus Fxy over m1. So that means this is not correct. The force that X exerts on Y is equal to F. x that's on y is equal to f. That is f y due to x is m2a. Remember m2a was m2 was less than m1, so this is not going to be true. The force that x exerts on y is less than f. The force that x exerts on y, that is f on y due to x, which is m2a, is less than f. I think that is very true because this force here is the same as this force here, and this force here is equal to f minus m1a. That means this force fxy is less than f. That's number one. So fxy is less than f. And remember, fxy is the same as fyx, which means that fyx is less than f. So the answer is going to be C. The force that x exerts on y is less than f. That is very true because the force that y exerts on x is less than f. So the force that x exerts on y should be less than f. As simple as that. A car of mass 750 kilograms has a horizontal driving force of 2.0 kilonewtons. Acting on it has a forward horizontal acceleration of 2 meters per second. What is the resistive force acting acting horizontal? So we have a resistive force by Newton's second law. The resultant force, which is Ma, should be equal to the forward force, the driving force is 2000 newtons minus the resistive force, which we don't now call it Fr. But the mass of the car is 750. The acceleration is 2. This should be equal to 2000 minus Fr. So we just press our calculator and make Fr the subject. So Fr is going to be 2000. Okay, maybe some students are not good at math. Fr is 2000 minus 750 times 2. So 2000 minus 750 times 2. So this gives me 500. So the frictional force is 500 newtons, which is the same as 0.5 kilonewtons when you divide by 1000. So the answer is going to be A. An object falls freely from rest in a vacuum. The graph shows the variation with the time t of the velocity v of the object. Which graph using the same scales represents the object falling in air? So if this is let's say this is the top speed in a vacuum, the acceleration is constant here. In air, we know that the acceleration must decrease because it is on the same scale. The acceleration should be decreasing, and then because it is in air, we don't expect the object to reach the same top speed. So one, the acceleration should decrease. The acceleration should decrease to 0, which means the gradient should decrease. Because the acceleration should decrease to 0, the gradient is going to decrease. And then we expect the top speed to be less. So first of all, we ignore A and D because A shows, this one is showing constant acceleration, and D is showing the acceleration is increasing. So A and D are wrong. The acceleration should decrease. Then B is going to be wrong because B is showing that the top speed is the same even when there is air. Yet the top speed should be less than. Both B and C show a decrease in the gradient, but the top speed should be less than. The top speed in air is not the same as the top speed in a vacuum for the same object. So the answer is going to be C. What is the kinetic energy? Okay, a rock of mass 2 meters traveling in deep space at velocity v explodes into two parts of equal mass, the same mass. one of which is then stationary. What is the kinetic energy of the moving part after the explosion? Okay, let's begin by conservation of momentum. Momentum is mass times velocity. Total momentum before explosion is going to be 2m times v. Total momentum before explosion. Then after explosion, one remains stationary. Its mass is, let's say it's mass, because they divide equally. One has mass m, the other has mass m, but one is remaining stationary, its speed is 0, plus the other one moves at a speed that we don't know. Let's say the other one, its mass is m times its speed, let me call it v2. So let me find v2. So v2 is going to be equal to 2mv divided by m, which becomes 2v. So the speed of the other one which moves is twice v. So let's find the kinetic energy. So kinetic energy Ek is equal to a half mv squared. So this is going to be equal to a half times the mass. The speed is going to be twice v squared. The speed is twice v. This is just the formula. Kinetic energy is a half mv squared, but v is twice v. Let me just use u. So the speed is twice v, but it is squared. So this gives you a half of m times 4 v squared, which gives us twice m v squared, which means our answer is going to be D. A horizontal metal bar PQ of length 50 centimeters hinged at NP. The diagram shows the metal bar viewed from above. Two forces of 16 newtons, 5 newtons are in the horizontal plane and act on end Q as shown. What is the resultant moment about P? So we notice that 16 is causing anti-clockwise moments about P and 5 is causing clockwise moments about P. But we have the distance from P to the 5 Newton force, the perpendicular distance. So I'm going to resolve this. The easiest way would be to resolve 16 Newton is in this direction here. In this direction here. So that the perpendicular distance will be the same. It will be 50 centimeters. So this is going to be 16. Using 30 degrees, that is 16 sine of 30. So I'll use 16 sine 30 and a distance of 50, and this will be causing anti-clockwise. 5 newtons with a distance of 50 will be causing a clockwise moment. So we want the resultant moment. So the resultant moment is going to be, I think 16 sine 30 times the distance. This distance here is the same as 0.5 meters. So this is going to be 16 sine of 30 times the perpendicular distance, which is 0.5, minus 5.0 times the perpendicular distance, which is 0.5. So the torque for the resultant moment is going to be 16 sine 30, I think that is 8 times 0.5, which is 4, minus 5 times 0.5, which is 2.5. And when you subtract 4 minus 2.5, I think that is 1.5 Newton meters. So the answer here is automatically going to be A. A cube WXZY has sides of length 2 centimeters and mass 24.0 grams. The cube rests on a meter rule of negligible mass. The geometrical center of the cube is vertically above the 70 centimeter mark. So this is vertically above the 70 centimeter mark on the scale of the ruler. The cube has a non-uniform density so that its center of gravity is not at its geometrical center. So the center of gravity is not at its geometrical center. The center of gravity of the cube is in the plane of the diagram. Okay. The rule rests on a pivot at the 50 centimeter mark. A mass of 23.4 grams is placed vertically above the 30 centimeter mark. The roll is horizontal and in equilibrium. What can be determined about the position of the center of the cube? It must be somewhere along a horizontal line that is 0.5 centimeters from line WX. Along a horizontal line, it must be somewhere along a horizontal line that is 0.5 centimeters from the line WX. 0.5 centimeters from the line WX. Okay, so it is saying it should be somewhere at a distance of 0.5 centimeters from the line WX. Okay, somewhere. So it means it can be very close to W, or it can be very close to X. So which means this is not going to be true. Let's check the second one. It must be somewhere along a horizontal line that is 0.5 centimeters from line YZ. That means it still means the same. It can be 0.5 centimeters from the bottom to this point here or to this point here. That means this is not true because equilibrium cannot be determined by that. It must be somewhere along a vertical line that is 0.5 centimeters from line WZ. So our measurement should either be from WZ going to the right hand side or from XZ going to the left hand side, because for equilibrium, the clockwise moments, the anti-clockwise moment should be called the clockwise moments. I don't want to check 0.5 because 0.5 will be, the 0.5 is going to be a distance measured from either 69 to the right or from 71 to the left, because 0.5 should be added to 69 to cause balance or should be subtracted from 71 to cause balance. After all, this side, if this is 30 centimeter mark, the moment this side is going to be 23.4 times 50 minus 30, which is going to be 20. And the moment this side is going to be the distance, let's say it is X. It is going to be, okay, let's say 16, let me just say 69 plus X. So if I say 69 plus X, it means the moment this side is going to be the mass, the 24.0 times 69 plus X. If I check X, I have to equate this to the other one. So I'll say 69 plus X is going to be 23.4 times 20 divided by 24, which is 23.4 times 20 divided by 24. And when I make X the subject, I have to take I have to subtract 69 minus that. So this is going to be minus, did I multiply this correctly? This is 50. No, there's a problem here on this distance. It is not 69. It is 69 minus 50. This distance is what? 69 minus 50. This is 19. So this should be 19, not 69. So this should be 19 plus X. So this should be 19. So 19 plus X should be equal to 23.4 times 20 over 24. So what is X? X is going to be, we have got 23.4 times 20 over 24 is 19.5, which means X is 0.5 centimeters. So it means X is 0.5, so it means on 69 I'm adding 0.5, so I must be measuring 0.5 from w's y, not from wx, not from yz, and so on and so forth. So the answer is going to be C. X is 0.5 centimeters from the 69 centimeter mark. So which means the answer is going to be C. A rigid sphere is held at rest on the seabed. When the sphere is released, it raises to the surface of the sea. The seawater has uniform density. Which statement about the sphere from its release until it reaches the surface is correct? Of course, if it is in the seabed, it means the upthrust is constant, because upthrust depends on the cross-sectional area, which is of course constant for that same sphere, times the difference in pressure, which is going to be constant because difference in pressure depends on the pressure on the top of the sphere and the bottom of the sphere. So if it is still fully submerged, the difference in pressure remains the same, so the upthrust remains constant. The sphere always moves with a constant acceleration. Of course, as it moves, there is a viscous drag which increases with motion, so the acceleration must reduce. So this one is not going to be correct. The sphere always moves at a constant velocity. Of course, as the drag increases, the velocity decreases, so this one is also not correct. The upthrust of the sphere decreases. The upthrust depends on the difference in pressure between the top and the bottom. So if this is the sea and this is the sphere, the upthrust always depends on the difference in pressure between the top and the bottom. Whether it raises, as long as it is still fully submerged, this height here, the difference between the top and the bottom of the sphere is always the same. So the upthrust remains constant. So this is also not correct. The upthrust of the sphere is always constant. So the answer is going to be D. What is the unit for density? So density is mass over volume. This is automatically wrong. The Newton cannot be a unit for mass. Millimeter power minus 1 cannot be a unit for volume. Centimeters squared cannot be a unit for volume. So the answer is going to be D. Micrograms can be a unit for mass, and millimeter power minus 3 can be a unit for volume. So the answer is D. Total energy input in a process is partly transformed to useful energy output. So the energy output is that one, and partly transformed to the energy that is wasted W. What is the efficiency of the process? So we know that efficiency is equal to the useful energy output over the total energy input. So the useful energy output is U, the total energy input is E in. I just multiply this by 100 to get this as a percentage. So this means the answer is automatically going to be A. An escalator is 60 meters long and lifts passengers through a vertical height of 30 meters, as shown. To drive the escalator against the force of friction when there are no passengers requires a power of 2.0 kilowatts. So if it is just alone, it requires this power. Now, if there are passengers, we must add some power to this. The power must be added to that. The escalator is used by passengers of average mass 80 kilograms. How many passengers are they? And the power to overcome friction remains constant. How much power is required to drive the escalator when it is carrying 20 passengers? So total mass is going to be 60 times 20. That is total mass. And it's traveling at that speed. Okay. So first of all, we know that power is equal to the energy divided by time. Power is the energy over time, and we know that the time it would take to move from the bottom to the top, because the speed is constant, is going to be distance over speed. So the distance from the bottom to the top is going to be 60 meters, and the speed is given as 0.75 meters per second. So that is the time it takes to move that distance. So the power is going to be the work done divided by the time taken. But which work is done? The work done is to lift the passengers through a vertical distance of 30 meters. So the work done is going to be force times distance divided by time, but the force is going to be the weight, which is going to be mg, then times the vertical distance, then divide this by time. So this is just the power to lift power. So lift power, let me call this one lift power, lift of passengers only. So the power here is going to be the mass, total mass is 60 times 20 times g, which is 9.81, times the vertical distance, which is going to be 30, divided by the time. Remember the time is 60 divided by 0.75. So it means the lifting power is going to be that. I'll just press my calculator. So I have 60 times 20 times 30 times 9.81. And I divide this by 60 divided by 0.75. So this is 4414 or 4,400. I'll just write 4,400 watts. That is the power to lift passengers alone through a vertical distance of 30 meters. So what is total power? So total power is going to be 2.0 kilowatts plus, this one is the same as 4.4 kilowatts. So plus 4.4, which gives us 6.4 kilowatts. So total power is going to be 6.4 kilowatts, which makes the answer to be B. A rock of mass of 40 kilograms is released from rest from a height of 20 meters. The surface above the surface of a planet. The rock has a kinetic energy of 32 kilojoules when it hits the surface of the planet. The planet does not have an atmosphere. That means air resistance is negligible. If it doesn't have an atmosphere, it means air resistance is negligible. What is the weight of the rock on the surface of the planet? So it is released. It loses kinetic energy. It is released from a certain height. It loses gravitational potential energy. So I will say the loss in gravitational potential energy should be equal to the gain in kinetic energy. So the loss in gravitational potential energy should be equal to the gain in the kinetic energy. So the loss in gravitational potential energy is mg times h should be equal to the gain in kinetic energy, which is given as 32,000. That is 32,000 joules. So mg, remember, is the weight of the rock. Mg is the weight. So the weight is going to be equal to 32 kilojoules divided by h. So that is 32 kilojoules divided by h, which is 20 meters. So we have 32 divided by 20. That is 1.6 kilo. Because the other one is in kilo, so it is 1.6 kilonewtons. So the weight is going to be 1.6 kilonewtons. So the answer is C. A metal wire stretches. The wire obeys Hooke's law. Which quantity has a value that does not change? Of course, that is automatically Young's modulus, because if the wire stretches, it means the extension has increased. If the wire stretches, remember strain is equal to extension over original length. If the wire has stretched, it means the strain has increased, so that one changes. Stress is equal to force over cross-sectional area. And remember, cross-sectional area, the cross-sectional area decreases if the extension increases. So it's like the stress if the stress increases if the wire stretches. So it means this one also changes. So it's only D which does not change, Young modulus, because um, if the strain increases and the stress, if the extension increases, the strain is increasing, and also the strain is also increasing. So Young modulus is equal to stress over strain. If this increases and this increases, of course, they will increase at the same rate because it's the same material. Increase in stress in extension is directly proportional to increase or to decrease in area. So it means the increase in stress is the same as is directly proportional to the increase in strain. So the Young modulus remains constant. So the answer is going to be D. An object is stretched until it reaches the elastic limit. Of course, we know that at the elastic limit, beyond the elastic limit, the material does not go back to its original length when the deforming force is removed. In fact, beyond the elastic limit, the material enters the plastic deformation or region of plastic deformation. Which statement must describe the stress on the object when it is at the elastic limit? So it is the maximum stress for which the object obeys Hooke's law. By the time we reach elastic limit, Hooke's law is no longer obeyed, because Hooke's law is obeyed up to the proportionality limit where the straight line stops. It is the maximum stress that can be applied to the object before it has elastic deformation. The maximum stress before. Of course, for elastic deformation, the material returns to its original length. Even when you have not reached the elastic limit, you can still have elastic deformation. So this is not correct. So maybe I can sketch a graph here of, let me sketch a graph of force against extension. So if this is a straight line, maybe then it changes. So here, Hooke's law stops here on the proportionality limit, then the elastic limit is slightly beyond. So this part here, the material can still go back to its original length, but Hooke's law is no longer obeyed. So it means even when we are at this point here, the material has already reached elastic deformation. It is still elastic deformation, but we have not reached the elastic limit. It is the maximum stress that can be applied to the object before it has plastic deformation. So the answer is C. As soon as I go beyond the elastic limit, then we reach plastic deformation. So the answer is going to be C. It is the maximum stress that the object can withstand before it breaks. This one is called the ultra tensile stress. The maximum stress that an object can withstand before it breaks is called the ultimate tensile stress. Ultimate tensile stress. So this is far beyond the elastic. It is at the end of the plastic deformation, at the plastic deformation region. Which statement about progressive waves is correct? They are always transverse. Of course, progressive waves can be transverse or longitudinal as long as they transfer energy. They can exist in solids but not in liquids. Of course, we know progressive waves. We have seen progressive waves travel through solids and in liquids. Including, but they can exist in solids but not liquids. They can travel through solids and liquids, but of course we know that electromagnetic waves do not travel through. Okay, they may not easily travel through solids, but they can travel through a vacuum. So transverse waves, progressive waves can also travel through liquids. So this is not correct. They decrease in frequency. They decrease in frequency as their speed increases. This is not true. The frequency of a wave depends on the source, not on the medium. So the answer is going to be D. They transfer energy away from the source. Progressive waves are those waves which transfer energy away from the source. The opposite is the stationary waves, which do not transfer energy. A cathode ray oscilloscope is used to determine the frequency of a sound wave. The diagram shows the waveform on the screen. The time-based setting is 5 milliseconds per division. What is the best estimate of the frequency of the sound wave? Okay, let me see how is it to find the length of one cycle in division. So we have 1, 2.5. So we are seeing that 2.5 cycles are represented by 1, 2, 3, 4, 5, 6, 7 divisions. 7 divisions. So it means 2.5 is 5/2 cycles. Those are 7 divisions. So it means one cycle is going to be represented by 2 times 7 divided by 5 divisions. That is 14/5 divisions. That is one cycle. So it means the period is going to be equal to length representing one cycle times the time-based setting. So 14/5 divisions times the time-based setting, which is 5, times 10 to the power of minus 3 seconds per division. So division cancels with per division. I think this is going to be 14 times 10 to the power of minus 3 seconds. That is the period. So to find the frequency, it is going to be 1 over the period, which is 1/14 times 10 to the power of minus 3. 1 divided by 14 exponent minus 3. So that is approximately 71. So the answer is going to be B. The warning signal on an ambulance has a frequency of 600 Hz. The speed of sound is 330 meters per second. The ambulance is traveling towards. So the ambulance is traveling with a constant velocity 25 meters per second towards an observer. The ambulance passes and then moves away from the observer with no change in velocity. Which overall change in observed frequency takes place between the times at which the ambulance is a long way behind the observer and when it is a long way in front of the observer? Okay, so let's say this part here is, of course, we know the observed frequency is equal to V over V plus or minus Vs times Fs. So this first part, when it is approaching, it is going to be minus. So here, the observed frequency here is going to be 330 divided by 330 minus 25 times the frequency, which is 600. Okay, then this part, when it moves away, the observed frequency is going to be equaling to 330 divided by 330 plus 25, then times 600. So towards, the frequency is higher, away the frequency is lower. So let's just press the calculator to check our values here. So I have 330 times 600 divided by 330 minus 25. So this is 649.18. 649.18 Hertz. Yes. Then let me check here. So this is the observed frequency when it is towards. Then observed frequency when it is away, it will be 330 times 600 divided by 330 plus 25. So this is 557.75. 557.75 Hertz. So I'm going to find the difference in the observed frequency by subtracting the two values. 649.18 minus 557.75, which is 91.4. So approximately 91 Hertz. So that means the answer is C. Okay, next, so the answer is C. Brief pulse of red, blue, and green light are emitted from the sun at the same time. The pulse travels the same distance, so same distance, same time. To reach Mars, assume that the pulses travel in a vacuum, so that means the speed is constant. So they are traveling, they are emitted at the same time. They are going to travel the same distance to Mars, and they travel in a vacuum, so they have the same speed. In which order would these pulses of light arrive at Mars? So all arrive at the same time. Of course, they all arrive at the same time because they are emitted at the same time. They're going to travel the same distance and the same speed. So they all arrive at the same time. Without wasting time, the answer is A. Since they're traveling at a constant speed, which is 3 times 10 to the power of 8, and they're going to travel the same distance, so the time is the same. Two coherent progressive waves from different sources meet at a point. Which condition must be satisfied for there to be zero resultant amplitude? Of course, if the amplitude is to be zero and we have two coherent waves, then their amplitude should be also the same. So that if a crest of 2 centimeters meets with a trough of 2 centimeters, 2 centimeters, 2 centimeters, they can cancel out to give a zero displacement. So they should have the same amplitude in that case. So the two waves must be emitted from their sources with the same intensity. They must be emitted from their sources with the same intensity. The two waves must be in phase with each other at that point. But of course, being in phase is not enough to produce zero resultant amplitude. It can result into a maximum amplitude. So this is out. The two waves must be traveling in opposite directions. Even if they travel in opposite directions, as long as they have different amplitudes, it doesn't give zero displacement. The two waves must have the same amplitude at that point. So when they meet at a point, to give zero amplitude, according to the principle of superposition, they should have the same amplitude. So that if a crest meets with a trough at that point, yet the amplitude is the same, they totally cancel out. So the answer is going to be D. So this is what gives us total cancellation. A corridor is 13.2 meters long and has closed doors that reflect sound at both ends. The speed of sound in the air in the corridor is 330 meters per second. What is the lowest frequency of sound that could create a stationary wave in the corridor with a node halfway along it? So we have a node here, and this end is closed, the other end is closed, so it means we have another node here. We always have nodes at the closed end, so this is what we have. Okay, so it means the length of 13.2 meters corresponding to a full wavelength, because this is a half a cycle and a half a cycle, so this is equal to a full wavelength. So frequency is equal to V over lambda, which will be V, that is given as 330, over the wavelength, which is going to be 13.2. So I just press my calculator, 330 divided by 13.2, which is 25. So that means my answer is going to be C. Water waves of wavelength lambda are formed in a ripple tank. The waves are diffracted as they pass through a narrow gap of width D. D is greater than wavelength. Okay. Which gap width and which wavelength will cause the largest decrease in the amount of diffraction? Remember, when D is very close to lambda, diffraction is maximum. Diffraction is maximum. So if we want to have the largest decrease in the amount of diffraction, either D should be much bigger than lambda, or lambda should be much bigger than D. Either way, D much smaller than lambda, or lambda much smaller than D to cause greatest. Remember, initially D is greater than lambda. So if we increase D further, it is like going to decrease diffraction. So let's see the options. If D is very close to lambda, we know that the diffraction is maximum. So let's first eliminate that. Gap width half lambda, wavelength half lambda. This one is going to give maximum diffraction. So this is out. Gap width twice D, wavelength twice lambda. Which gap width and which wavelength will cause? So this, if they are approximately equal, then it means that will give maximum diffraction. Now, gap width is half D. So we reduce D by half. And remember, D was bigger, so we reduce it by half and we increase wavelength. It is like making, no. Let me go back to A. If we reduce D by half and we reduce wavelength by half, we have not caused any change. Still, D is greater than lambda, so it is almost the same thing. If we double D and double lambda, still D is greater than lambda, so it's almost the same thing. It's almost the same as the condition given in the question. That's why A and D are wrong. Then let's check B. If I reduce D, remember D was already greater than lambda. If I reduce it, that is fine. I'm bringing it close to lambda. But again, I'm doubling lambda. So that means I'm making lambda bigger and I'm reducing D. When I make D smaller and increase lambda, it's like I'm trying to make them very close, the wavelength very close to the size of the gap, which will make diffraction maximum. So the answer is going to be D. D was already bigger, now double it. The wavelength was smaller, now reduce it. So it means the wavelength in this case, or the gap, is going to be much bigger than the wavelength. Because D was already bigger, you doubled it again. The wavelength was already smaller and you reduced it, you made it even smaller. So it means the gap is much bigger than the wavelength. So diffraction is going to be minimum. So the answer is going to be C. Two loudspeakers X and Y emit sound waves that are in phase and of wavelength 0.75 meters. An observer O is able to stand anywhere on a straight line that passes through X and Y as shown. The observer stands at a point where the sound waves from X and Y meet in phase. They meet in phase. So that means the phase difference could be zero. That means there is constructive interference. So if they meet in phase, either the path difference should be an odd number multiple of wavelength, because there will be constructive interference. There will be constructive interference. So what could be distances OY and XY? So remember, for constructive interference, the path difference is n times lambda, where n should be 0, 1, 2, 3, and so on and so forth. So let's first find the path difference. The path difference is going to be OY minus or X. The path difference is OY minus OX. That is the path difference. But also, XY, distance XY is also the same as OY minus OX. The difference between X and Y is OY minus OX. So that means XY, which is the path difference, should be equal to n lambda, which should be the same as OY minus OX. XY is the path difference, which should be n times lambda. It should be the same as OY minus OX. Okay, so I am just going to make n the subject and check if n is a whole number, then that is constructive interference. So I'll just check, I'm just going to check xy alone. So n is going to be xy, which is the path difference, divided by the wavelength. So let me check. N equals to 0. No. I'm going to check these values. I'll just press my calculator for the first one. If xy is 3.5 divided by the wavelength, which is 0.75. So this is not a whole number, so this is out. So I'm saying this should be, n should be what? A whole number for constructive interference. N should be a whole number, 0, 1, 2, 3, and so on and so forth. I'll check the second one, 2.75 divided by lambda, which is 0.75. That is not a whole number, so that is out. I'll check the third one, 2 divided by 0.75. That's not a whole number, so that's out. 1.5 divided by 0.75, I think this is 2, so this is a whole number. So the answer is most likely going to be D. The answer is most likely going to be D. N should be a whole number for constructive interference. Light of a single wavelength is incident normal on a diffraction grating. The resulting diffraction pattern is displayed on the screen. Which changes make the first orders of intensity maxima further apart from each other on the screen? So remember, for a diffraction grating, lambda is equal to AX divided by D. So I want you to notice X is directly proportional to lambda. Remember, X is the distance between the intensity maxima or intensity minima. X is also directly proportional to D. X is inversely proportional to A. So we want the change which makes the first orders of intensity maxima further apart. The first orders of intensity maxima. That means X will also have increased. If this is a diffraction grating and this is the screen, if this is the first orders, n equals to 1, n equals to 1. So we want them to be further apart. I think I've used this is not light of a single wavelength. So sorry. This is not a diffraction grating. This is double slit. Sorry, for diffraction grating, we know that n lambda is equal to d sine of theta. So we want the first orders of the intensity maxima to be further apart. N is equal to 1. For them to be further apart, of course, sine theta is directly proportional to lambda, or theta is directly proportional to lambda. So lambda is directly proportional to theta, and theta is inversely proportional to d. So placing the screen closer to the diffraction grating, the screen distance is not affecting anything here, so this is out. Remember, n is the order, lambda is the wavelength, d is the slit separation, and theta is the angle of diffraction. So the angle of diffraction is the one which determines how far they are from the center. Using a diffraction grating with less separation between adjacent slits. So when d is smaller, then theta is bigger, so that is further apart. So the answer is going to be B. So automatically the rest will be wrong. Using a diffraction grating with more slits, this one just affects the intensity. More slits just increases the intensity. Using light with a shorter wavelength, if the wavelength is smaller, then theta is also smaller because the wavelength is directly proportional to theta. For a current carrying wire, the current can be calculated using the equation I is equal to ANVQ. What is the meaning of N? Of course, we know N is the number of free electrons per unit volume. the number density of free electrons per unit volume, the number density of charge carriers per unit volume. So let's check number of charge carriers in the wire. That is not true, it should be per unit volume. Number of charge carriers times volume, that is wrong. Number of charge carriers per unit length, that is wrong. So the answer is D. Number of charge carriers per unit volume, that is N. The number of free electrons passing a point in a wire in 24 hours is given by that. 6.0 times 10 to the power of 23. What is the average current in the wire? Of course, we know that current is equal to total charge per unit time. Charge is the number of charge carriers in the wire times times the charge of each charge carrier over T. Now, this capital N is not the same as the previous small n. Capital N is total number of charge carriers, not number of charge carriers per unit volume. Then this is going to be equal to the number of charge carriers is 6.0 times 10 to the power of 23. The charge of each charge carrier is 1.6 times 10 to the power of minus 19 because they are electrons. The time is 24 hours, which will be 24 times 3600. I'll just press my calculator. 6 exponent 23 times 1.6 exponent minus 19 divided by 24 times 3600. So this is 1.111 recurring. So the answer is going to be B, 1.11 recurring amperes. In the circuit shown in the lamp P is rated 250 and 250 volts, 50 watts. So what is this resistance for P? Resistance here is going to be, I'm using power is equal to V squared over R. So R is going to be equal to V squared over the power. So the resistance here is going to be 250 squared divided by 50. 250 squared divided by 50. So the resistance here is 1250 ohms. Then lamp Q is rated at 250 volts, 200 watts. So the resistance here is going to be 250 squared over 200. 250 squared divided by 200. Which is equal to 312.5 ohms. So assume the two lamps are connected in series to a 250 volt power supply. Assume that the resistance of each lamp remains constant. Which statement most accurately describes what happens when the switch is closed? When the switch is closed, lamp P emits 4 times as much power as lamp Q. Let's check that. I will write power for P this side. So power emitted by lamp Q is going to be I squared times R. Remember the current is the same because they're in series. So the power this side is going to be I squared times 1250. That is the power for P. Then power for Q, I'll write this side. Power this side is going to be I squared times 312.5 ohms. Let me check the ratio. The ratio of power for P over power for Q is going to be I squared times 1250 divided by I squared times 312.5. So this is P over Q. The ratio P over Q. So this is going to be, I think this is automatically 4. 1250 divided by the answer, that is 4. So the power for P over Q is equal to 4. So it means power for Q is 4 times power for Q. Power for P is 4 times power for Q. So the answer is automatically A without checking the rest. A piece of wire has a length of 0.80 meters and a diameter of 5 times 10 to the power of minus 4 meters. The IV characteristic of the wire is shown. What is the resistivity of the wire? Of course, to find the resistivity, I need the resistance first. The resistance here is going to be 1 over the gradient from V equals to IR. It is a graph of I against V. Or I will find this as change in V, change on the x-axis, over change in the y-axis. So the resistance is going to be 10 minus 0 divided by 5, which is going to be 2 ohms. That is the resistance. And we know that resistance is equal to rho L over area. And of course, we know that area is going to be pi d squared divided by 4, or pi r squared over 2. But because radius is diameter over 2, it's the same as pi d squared over 4. So we want resistivity. So resistivity rho is going to be R times A divided by L. So I'm substituting. R is 2. The area is going to be pi times diameter, which is 5 times 10 to the power of minus 4. But this is squared. Then we divide this by 4. Then divide by the length of the wire, which is 0.80. I'll just press my calculator. 2 times pi times 5 exponent minus 4, and this is squared. I can first divide by 4, then I divide by 0.8. So I'm getting 4.9 times 10 to the power of minus 7. So this is ohms per meter. So the answer is C. Sorry I had to delay because I explained too much. So 10 cells, each of EMF 1.5 volts, are connected together as shown. What is the combined EMF between the terminals X and Y? So let's check which cells are pointing to the left. 1, 2, 3, 4, 5, 6, 7, 8. 9 cells are pointing to the left. 1 cell is pointing to the right. So I'll say 9 times 1.5, that is positive, minus the other one which is pointing to the left is just 1, so I'll say minus 1.5. So 9 cells are pointing to the left, so total EMF to the left is 9 times 1.5. Then I subtract the EMF to the other side, that is minus 1. That is Kirchhoff's second law, so the answer is 12. So the answer is C. A cell of EMF E and internal resistance R is connected to a variable resistor as shown. The resistance of the variable resistor is gradually increased from R to 3R. Which graph shows the variation of potential difference across the internal resistance with the PDV across the variable resistor? Okay, so first of all, we know that the EMF, I think I'll use this space here. The EMF E must be equal to the capital V plus small v. And the graphs given are for small v against capital V. So I'll make small v the subject. So small v is going to be equal to cap E minus capital V, or I will say small v is equal to negative capital V plus the EMF E. So when the resistance of variable resistor is R, it means EMF is going to be divided equally. So when resistance of resistance of the variable is the same as internal resistance. It means when the resistances are the same, remember the current is the same, so the EMF is going to be divided equally. So it means V is going to be equal to capital V. So it means when small r, when the internal resistance is the same as the resistance of the variable resistor, then the PDs across them is the same, so it means the PD for the smaller resistor is going to be a half of E. They divide the EMF equally, so that would be a half of E. So our graph should be at there should be a point where both of them have where V and capital V and small v are the same. So all our graphs have that point. So that one is not a good checking point. But then let's check what happens when the resistance of the variable resistor increases. So when R increases for the variable resistor, remember the current is the same, so that means V increases. And if V increases, remember there is a negative in front of V. So it means smaller v decreases. So smaller v decreases. So let's check first of all. So it means we eliminate D and we eliminate C, because D and C are showing that as V increases, small v is also increasing. That is not very true. Okay, so we are remaining with the 2. So since as V increases, capital V increases, small v decreases, it means the maximum value of small v must be 0.5. That is the maximum value of small v. Automatically B is wrong because B is showing that the maximum value of capital V is 0.5, yet this could increase up to E. So it means the answer is going to be A. As capital V increases, small v decreases. Remember, there is a point where both of them have the same EMF. I mean the same value, which is a half of E, which is 0.5 E. So the answer is going to be A. Each of Kirchhoff's two laws presumes that some quantity is conserved. Of course, we know first law, that is conservation of charge. Second law, that is conservation of energy. So which law states Kirchhoff's first law and names the quantity that is conserved? So first law is charge. So we eliminate energy. So it means B and D cannot be correct. First law is conservation of charge, which is the sum of currents into a junction equals the sum of currents out of junction. So the answer is A. The algebraic sum of currents into a junction is 0. That means if you say currents entering positive, currents leaving negative, when you sum them up, they should give you 0. So the answer is A. A cell has an EMF of 80 volts and negligible internal resistance. The cell forms part of a circuit as shown. The reading V1 is 4 volts and the reading V2 is 4 volts. Okay. What is the resistance of resistor R? So let's start from this part here where reading is V2. Let's first find the PD of V2. The PD corresponds to V2. So V2 is going to be equal to the current, of course, total current I into the circuit is the same current here. So it's going to be the current I times total resistance. These are in parallel, so it is product 4 times 4 over the sum, which is 4 plus 4. So this is times 4 times 4 over 4 plus 4. That is total resistance in parallel. And I think this is, remember V2 is 4 volts, so this is equal to 4.0 volts. So what is I? So I is 4 times 4, which is 8. Which is 16 divided by 4. Okay, let me just say I times 16 over 8, which is 2, is equal to 4. So it means I is going to be equal to 2 amperes. 16 divided by 8, which is 2. So the current is 2 amperes. So I is 2 amperes. It is the same current here. This is 2 amperes. So it is the same current through V1. So let's check. V1 is also going to be the current times R. So V1 is 4 volts. The current is 2 times the resistance, which is R. So it means R is going to be 4 divided by 2, which is of course 2 ohms. So the answer is going to be B. In the circuit shown, the cells have negligible internal resistance and the reading on the galvanometer is 0. What is the value of resistor R? Okay, so this is a simple question. If the reading on the galvanometer is 0, there is balance. So it means the resultant current of the galvanometer is 0. So the PD across 9 volts, 9 ohms, is the same as the PD across 6 ohms. So the PD at balance, the PD across 9 volts is the same as the PD across the 6 ohms, not 6 volts. So the PD across the 9 ohms is going to be equal to, so I'm going to use the potential divider formula, that V out is equal to R1 over R1 plus R2 times V supply. So V supply is 4 volts. Let's say R1 is 9 ohms. So this is going to be 9 over R1 plus R2, which is 9 plus 3. Then times the voltage supply, which is 4. From my calculator, I have 9 divided by 9 plus 3. Then times 4. So this is going to be 3 volts. So it means the PD here is 3 volts. That is going to be the same PD here, which is 3 volts, because they're in parallel. 9 ohms is in parallel with 6 ohms. So now it takes me to the lower part. If the PD here is 3 volts, what is the PD here? So the PD here is going to be 9 minus 3, which is going to be 6 volts. So the PD across R is 6 volts. So the question is, what is the value of resistor R? Remember, I'm now going to again to use the potential divider formula. The PD across R is going to be the resistance R over total resistance, which is R plus 6, then times the voltage supply there, which is 9.0 volts. So PD across R is 6, the resistance is R over R plus 6, then times 9. So I'm just going to cross multiply. So I have 6R plus 36 is equal to 9R. So it means 3R equals 36, which makes R to be 12 ohms. So the answer is going to be C. When alpha particles are directed at gold leaf, almost all the alpha particles pass through without deflection. So that means most of the atom is empty space. A few alpha particles are deviated through large angles. Maybe these ones came close to the nucleus, which is positively charged. What are the reasons for these effects? So just look for something related to that. Most alpha particles have enough energy. That is, it should be empty space. Most alpha particles miss all gold atoms. It should be mostly, an atom should be mostly empty space. The gold nucleus is very small, so most alpha particles miss all nuclei. I think that makes sense. 2. Occasionally the path of an alpha particle is close to the nucleus. That's when we have a deflection for a few alpha particles occasionally, which makes a few alpha particles come close to the nucleus and they are deflected through large angles. So the answer is going to be C. I think atomic particle physics is very easy. A nucleus X is radioactive and decays into a nucleus Y. X and Y are isotopes, so that means they have the same proton number, different nuclear number. Which combination of particles could have been emitted during the decay process? So X, A, Z should give us Y, where Z should remain the same. Of course, A can change. Let's check the first one. The first one says it emits one alpha particle. Let's check alpha for 2, and one beta particle, beta, that is 0, -1. So it means there is no Z is not balanced here. This side we have Z, this side we have Z plus 2 minus 1, which is Z plus 1. So Z is not equal, so this is not correct. That is not an isotope. The second one, X Az, should give us Y, where Z remains the same, plus 1 alpha particle, which is alpha for 2, plus 2 beta particles should be twice beta 0 minus 2. Let's check on the left hand side to see if we remain with Z. On the right hand side to see if we remain with Z. So on the right hand side, we have Z plus 2 times negative 1, which is negative 2, which is Z. So that means the proton number is conserved, so the answer is going to be B. Because they're isotopes, the proton number should remain the same. And lastly, a positively charged meson consists of a quark and an antiquark. What could be the quark and antiquark? What could be the quark and antiquark? It is positively charged. So we're going to check the charges. Charm and ant-up. Charm is positive 2 over 3. Ant-up is negative 2 over 3, which gives us 0. So this is out. Down and ant-top. Down is negative 1 over 3e plus ant-top. Our top is 2 over 3e, so ant-top is negative 2 over 3e. So I think this gives us negative e, which is going to be out. Then strange and antibottom. Strange is negative 1 over 3e plus antibottom is 1 over 3e, which gives us 0. So this is out. So the answer is going to be D. We can check. Up is positive 2 over 3e plus anti-strange. Remember, strange is minus 1 over 3e. And anti-strange is positive 1 over 3e. The LCM is 3, so this is 3e over 3, which is positive e. So this is positive. For those who don't know, the charges, I will say up, top, charm. All these ones have a charge of positive 2 over 3e. Then the opposite, and up, and top, and charm. These ones just have an opposite charge, which is negative 2 over 3e. Then top up is down, opposite. Then top is bottom. Charm is strange. These ones have charge of negative 1 over 3e. If I get the anti-quarks, anti-down, anti-bottom, and strange, these ones will have a positive 1 over 3e. So you need to know these charges to be able to pass such a question. So the answer is D. I think I've tried my level best. I know I've gone past time because I was trying to explain a lot. Until next time, bye-bye.